Hi, Mike Violette with EMCTV.tv at the 2015 International Symposium on EMC in Dresden, Germany. I'm happy to be with Don Heirman, Vice President of Standards. Don, what's new in the standards world?
Well, thanks, Mike. I thought it would be of use, like we did a couple of years ago, to present the latest activity in the EMC Society standards arena. And as you might imagine, there's a lot more activity as years progress. So I'm going to briefly go over some of the older standards and where their status is, but then I'm going to spend a little more time on the new study questions and the new questions and actually challenges that we're facing. One of the things we've done in the standards arena under Alistair Duffy as the chairman of the Standards Development Education Committee is reach out to other technical committees within the society, and also to keep the ears to the ground, so to speak. And when he attends a meeting or I attend a meeting, we decide maybe we should go after some new technology that doesn't exist anywhere else. The EMC Society has a very unique space, if you will, because many, if not a large percentage of our standards simply are not covered in international standards like those coming from the International Electrotechnical Commission. So one of the things is my chore is not a chore, but my pleasure is to, once it's published, to see what can be introduced into the international arena. So, and I'm talking about the IEC, which we call the big I's because they're centered in Geneva along with the United Nations. And many people use those because it's international in their eyes, although our standards are universally used internationally.
Sure, like all kinds of IEEE communication standards. 802.11.
802-11 is .11 is, and the ABCDEFGHN is used virtually everywhere, and that's the whole point of standardization. Right. So I think I would like to just start chatting, and let me do that. I'm looking at my laptop computer because it turns out I just finished a report to the EMC Society Board of Directors, and so therefore it's as current as we can get because our standards meeting just ended, well, the first part in Monday of this week here in Dresden.
Fire away. Fire
away. Well, first of all, we want to give credit to our officers. Alistair Duffy, De Montfort University in the UK, is our chair. Our vice chair is Craig Fanning from Elite Electronics, and our secretary is Gary Pettit, newly retired from Intel and now a member of his own company. So let's just get off to the start. I'll do it by standard number, and I'll give the general title. Standard 139 is on industrial, scientific, and medical equipment testing for emissions. It's a current standard, but it's one that is primarily based on in situ measurements in the field, and really there's very few that's a reliable, repeatable measurement that you can use in the field, and this is one aspect that maybe we can get this more universally associated with that measurement. Second one, and I'm just not second, I'm just going to go through the list. Standard 187 on TV receiver emission testing, especially for spurious, is really been cranked up. The working group chair attended the Consumer Electronics Show in Vegas in January and got 7 or 8 people to work on this standard. And there's a need for specific filters when you do this measurement that's not generally available in standard emission testing. Then there's two.
Now, why wouldn't they just pick off-the-shelf filters that everybody can get?
Well, the answer is it is off the shelf, but its unique application, the test setup, is the critical link apparently.
Yeah.
And maybe the group will come up with some more. The idea is, you're quite right, Mike. We don't want to have something that is so simple. Why bother?
Yeah.
So I think this case will just say stay tuned.
Okay.
At this moment.
Okay. Well, I hope there's lab representation on that working group.
There is people that used to work at Sony Laboratories, and obviously and Samsung is about to join. So at least the manufacturer side. But you're right. If it goes to a vote, it has to be balanced with the manufacturers, users, and users would be the test laboratories.
Yep. Right. Okay.
And please interrupt me whenever you wish, because I'll stop. I've been known to stop every 3 hours. We have a couple of standards on shielding effectiveness measurements. The classical one is for a test chamber shielding effectiveness, and that used to be the old mill standard 285, and now it's IEEE standard 299, which has been picked up by the military as well as others. And that's for the larger chambers. We also have 299.1, which was published, that covers chambers where the maximum linear dimension is between 1/10 of a meter, never small, to up to 2 meters. And that is had some usefulness in some of the huts that are, for example, in a communication area that's sitting out in the front lawn or by a gas station, to see the effectiveness of that shield. And that is current, and there's no real work identified at the moment. We have one I think is very interesting also on EMI site surveys. For example, if I take an antenna around this room here in the exhibit area, you can imagine the variability of the fields you would get. Well, a lot of the customers that use this used this in the past. We're in a building that they couldn't afford shielding, or if they could, it could maybe one wall if it's close to a line of sight from a transmitter. And they would, we would do a site survey, moving the antennas around, and we'd find essentially a sweet spot where the field is low. So they would put their most critical part of their installation in that place. So this gets away from being in a semi-anechoic chamber or a shielded environment. So that one is under study now by our technical committee number 3, and I'm looking forward to that moving ahead. I was part of writing that standard, but it's now virtually on a 20-year-old window. It's time to use modern instrumentation. In those days, we didn't have spectrum analyzers, for example. Let's continue on. We have a standard on field disturbance sensors. These are the kinds that you walk into a shop, it's anti-pilferage and that kind. The standard at the time we wrote it, all those systems were above 300 megahertz, and what we need now is to go down to much lower frequencies, because that's what exists with some of these big loops. So that is working for trying to get information on. And I'll just continue on. We have one, an RF absorber, 1128, which if you go around the floor here to those manufacturers that make absorber material, they'll say on their spec sheet meets 1128. Well, it meets it to 5 gigahertz because that's as far as 1128 goes. Well, we use chambers much higher than that. So their challenge is to move that up to 18 gigahertz, which is not as simple as we might think. So let's move on then. We have another interesting one on near-field magnetic and electric field measurements, the so-called standard 1140. Although it was designed initially for measuring emissions near into a video display terminal, which is cathode ray tube technology.
What's that?
What's that? Yeah. Cathode ray tube, the old TV sets before we went to planar LEDs and all sorts of plasmas and
sexy LEDs.
Yeah. Well, believe it or not, there's still some of those things sitting out there. But the bottom line is we want to remove the terminals and just say near field measurements.
There you go. That would be a good update. Just
update the darn thing. We have a couple. We have one on a probe gasket. Gasketing characterization. Again, that went up to 18 gigahertz, but the community says we want to make measurements up to 40 gigahertz on the shielding effectiveness of gaskets. And along with that, we're working on probe calibration, which is useful at the present moment, but as we keep getting higher and higher in frequency, there's some projects that work at 200 gigahertz. And how do you measure a field with any kind of sensitivity at that kind of frequency? So I'm looking forward to what might come out of that work. I'm just going to move on to a couple others. Believe it or not, we have electromagnetic compatibility, and there's computational electromagnetics. We have 2 standards, 1517.1 and .2, and that deals with how to validate modeling and simulation techniques using finite difference time domain and a host of other techniques. And I think this has a real interest to the community, because if you can generate a estimate by computational methods without having to go in the lab and take data forever, it seems, and there's an interest in that. By the way, the IEEE EMC Society is working on another journal with the Macrowave Theory and Techniques and Antennas and Propagation Societies to deal with computational methods. And guess what? 1597.1.2, I'm sort of in charge of writing up that this should be used. And wouldn't that be nice if we had 3 of the major, well, at least 2 of the 3 that are major societies. So those 2 are in work. We just published one which is kind of interesting. Of course, to me, everything's interesting. But this is one on intentional EMI. This is looking at, let's face it, a terrorist attack on an electronic system, such as building an amplifier and an antenna, a small amplifier, and putting it next to an ATM machine and destroying the electronics, the computer part of it. This looks at how that might be done. And by the way, this is in a briefcase size. You can build one of these things. And this standard looks at the aspect of that and how you might mitigate against it. Clearly, it's just a first attempt, but it's getting a lot of interest.
Framework, yeah.
Getting a lot of interest that way. Another one, which is a kind of a new area too, although it's been tried 30 years ago. What if you do testing at sub-assemblies of a larger product for emission and immunity, and then you make a change, and can you then look at the change in those sub-assemblies to predict whether the product fully assembled continues to pass or continues to fail?
Of course you can.
Within 30 dB, right? Well, the skepticism was quite high, I must admit, but it's published, and I think it's worth a look-see, because maybe on certain subcategories it might work.
Yep. Great.
And that's standard 1688, by the way. Some new projects. Now I'm going to shift from what we've been doing to maybe some more exciting work in new areas. We have a project on looking at power line noise with the poor grounding and of the neutral, for example, and creating arcs and nonlinear junction and so forth, causing interference. This is one of the problems we have is people think about it, but they don't record it in a particular way that you can take action. Well, this standard is a recommended practice for reporting that, if you will. Then another one that just came up from Technical Committee 10, which is working on signal integrity and power integrity. They want to measure the interfaces between parts of the digital network, and they want to measure it, believe it or not, up to 50 gigahertz.
Wow. Sure.
And they had 30 people on the committee.
Wow.
Boom, just like that. So with the stress we are giving SIPI at the symposium, we're starting to get some fruits out of that in the standards world.
Good. It's getting some gravity, getting some traction.
And a couple of pending projects, and maybe we'll close it with a chat at the end. We're still trying to have a system of measuring the planar shielding of material. The classical case is you put a meter by meter, and then you look at an input to an output, but it needs some improvement because of edge effects and things of that nature. People want to shield equipment or components on a PCB, printed circuit board. Mm-hmm. Now you're talking about a shield that's an inch, or 2.5 centimeters by 2.5 centimeters by 4. And how do you, in the classical cases, you would put a source inside and measure outside. Well, how are you going to put a source inside something that small? So they're looking at techniques where they look at the insertion characteristics of cables with and without the shield. And to me, that's a great way of, because there's no way we're going to put a source inside to measure that. Here's an interesting one. If you go into, let's say you have a laptop computer or your smartphone, and you want to, there are people that can sniff the signals coming out of that, or worse yet, put a signal into it that might burn it up, destroy it. They now have, and it's on the marketplace, pouches that are shielded.
Wallets and pouches.
But the shielding effectiveness is stated to be 100 dB.
Sure.
Well, that's the material.
Yeah.
But there's a latch, and it's maybe Velcro.
Yeah.
So we're going to look at putting a small source inside, a pouch that expands, and see with the various type of latches and the essentially the breaches in the shield, what really the number should be. And by the way, there are competing people in the marketplace now. Mine is 110 dB of shielding. Hey, mine's 115. Mine's better.
Yeah.
So we gotta get rid of.
I got one that's 180.
There you go.
Yeah.
But it's not 175 because that's the competitor.
That's right.
The last one, and I think I'll conclude here, is a lot of EMC now is getting into functional safety. In other words, over the life of a product, what kind of immunity should be built in. And along with that is called risk analysis. And that's very popular in the medical community.
Well, I wouldn't say it's popular. It's not a favorite thing.
Well,
anyway, it's now a part of the whole process.
The FDA once said in 60601-1-2 is got it.
Yeah, it's driving us crazy.
It's starting to, exactly.
So be careful.
Exactly.
Be careful what
you do. I want you on the committee, Mike. Come on.
I mean, what's the risk?
And
anyway.
You're right. It's subjective a lot.
Yeah.
And it deserves. So if we are in the business, Keith Armstrong, UK, is chairing that along with Bill Radasky, and they know what they're talking about. But and they also are practical.
There should be practical aspects of risk management.
So I think let's have some hope for it.
Good. All right, Don.
And maybe I'll just conclude as a lot of the work we're talking about now, we've taken, if you look at the charter and the bylaws of the society, all the technical committees should be involved in standardization. But I can count on 2 fingers how many that are. So what we've reached out to the technical committees, depending on the subject, can you help with your expertise input? And this has the advantage of getting a lot of new ears and eyes, and we feel fairly comfortable about that. So maybe at this point, we kind of say these working groups are open.
Lots going on.
And there's no charge to be on a working group.
So if someone wants to engage on this, how do they get a hold of you?
Well,
who would they contact?
Well, best is to contact Alistair, APD. Well, I'll tell you what, it's easier to get through me because I can find where he is. So it's d.heirman, Heirman, at IEEE.org.
It's right there.
And it's right there. And I'll make sure that they get in contact with the right people, even if I have to go directly to the working group chairs.
Great. Well, this is a great place to conclude, Don, because I know that standards in Germany are important, and I know that the glasses that they have a fill line with the amount of the liter that they're actually pouring. And I notice a gentleman over there has got a standard glass of beer. So at this point, we're going to say thanks. This is Mike with EMCTV.TV. Thanks, Don Heirman.
Well, thank you.